Welcome to the NPTEL course on power system protection. We are continuing with distance laying. In this lecture, we will see the issue with load encroachment, and our discussion will be the issue with distance relay in the case of load encroachment perspective, and then what are the different mitigation techniques being used in distance relays. Let us come to the issue first. So, we have a 2 bus system and there is a power flow. So, the corresponding load which will be seen at bus M, during that time the corresponding voltage and current as observed by the relay R M, accordingly an apparent impedance will be seen by the relay. So, that apparent impedance is the issue of the corresponding discussion matter in this case. So, note that we are not considering any fault here, we are only observing the load patterns through this line which the relay will observe. For any power flow, complex power flow P plus J Q, the corresponding current here that becomes equals to P minus J Q upon V conjugate. So, that relation is known to us. Now, we will see consider the corresponding apparent impedance which the relay will see during a load flow situation, normal load flow situation. This load means in the power system, high voltage system is balanced in nature. So, the relay will consider this as a balanced situation, and whatever discussions we have made for 3 phase fault or so, this will be a similar situation for the relay. So, therefore, the relay will consider any phase voltage upon any phase current for the Z apparent calculation, and that is why I talk about here Z apparent equals to V m upon I m, and then substituting this corresponding I m from this relation, we get to consider this also equals to V m square upon P minus J Q, the corresponding power, real power and reactive power flowing through the line. So, this leads to another expression V m square magnitude square upon P square plus Q square into P plus J Q, the corresponding P and Q flowing through the line. So, we see here 3 terms B square, P square plus Q square in the denominator and another P and Q in the numerator. So, the load impedance, this is a loading condition. So, load impedance measured by the relay is a function of voltage. The load impedance, this is a loading condition, load impedance seen by the relay at that situation is a function of voltage, the direction of power flow and the corresponding power factor of the load. The apparent impedance seen by the relay Z apparent at this moment is proportional to the square of the magnitude of voltage. So, that leads to situation, if the voltage drops from 1 power unit to lower value say 0.9 pu, from 1 power unit to 0.9 pu without change in load, assume that, then the square of 0.9 means 0.81. So, the corresponding Z apparent will be considered fall to 80%, 81% what was there at 1 pu voltage. If the voltage dips to 0.8 pu, the Z apparent you consider as compared to 1 per unit of voltage will go to the 64% of that value. So, these kind of situations may happen here consider this bus, if the corresponding bus may be connected to other lines and a fault may be observed in other lines and the corresponding voltage will be drop here. So, at that time you consider that during this condition of the loading condition of the line, how the corresponding voltage will be seen by the R m, or any other situations that may also lead to low voltage situation like a high loading situation and so. the Z apparent is inversely proportional to the apparent power as compared to these two terms. So, if the power increases by 50% apparent power, then the Z apparent becomes equals to the Z apparent falls by 66.7% and the power becomes double, then we say consider the Z apparent will fall by 50%. So, that you can say that in this situation you can say that in terms of that. So, this becomes twice of that one. So, this becomes 4 times and this becomes twice. So, only 2 factor will be there. So, that leads to 50%, 0.5. So, in both the situations when voltage dips or power flow increases, we see that the Z apparent significantly reduce. That reduction in apparent impedance is of concern now. Will it enter to the relay characteristics? Then the relay may malfunction. Take a situation of 400 kV line here and the Z apparent was at a particular instant was having at this condition. Now, there is a significant power flow increment here in this line. In the second case, the corresponding apparent impedance seen becomes inside the zone 3 for this arrangement for the relay RM. So, there is a long line issue and the corresponding power flow increases significantly. So, from earlier value to this value, but this value enters inside the zone 3. So, what will happen that in this case if the corresponding load persists for longer period of time, the delay time set for zone 3, then the zone 3 at this point will consider this as a fault situation and operate pick up, that becomes a malfunction. So, this is a security concern. So, we say that the load encroaches into the characteristics, the Z apparent seen enters into the relay characteristics during loading condition, particularly heavily loading condition, then that creates unnecessary tripping, security issue. So, during peak load condition, high power flows to the line, voltage may further dip, Z apparent likely to fall significantly and may be significant low value and it may be inside the zone characteristics. So, because zone 3 is the outer one, larger area at coverage. So, that will be more vulnerable to the load encroachment issue. This may be prevalent, this kind of situation for long transmission lines, because coverage will be more for the zone 3, heavily loaded transmission line and the large impedance zones associated with zone 3 and so. So, we consider if it is a long line, then the corresponding area coverage will be more. If it is heavily loaded transmission lines, we have already observed P plus JQ term will be more, and if it is a large impedance zones, if the subsequent lines are having also longer, then the zone 3 will be further, you can say that larger. So, the Z apparent falls inside any of the characteristics, then the relay will pick up subject to it meets the corresponding time associated time delay. Now, such a pickup during loading condition, this is not a fault condition, then it is a violation to the security of the system. So, we have already defined what is security of protection and the dependability. Security means when there is no fault, the relay should not operate. When there is no fault in the assigned section, assigned line for which the relay is taking care, if the relay trips, that becomes a malfunction, that is a security issue. Such load encroachment problem was being observed in many blackouts in the globe. Then what is the solution in this to overcome the corresponding load encroachment in longer lines or heavily loaded condition and so. We will discuss few methods that is being those are being used. First one, change the impedance relay characteristic from mode to lenticular. If a line is expected to be considered a load encroachment issue. So, what to do that the corresponding characteristics, say zone 3 characteristics, instead of having considered a circular like mho here, you make it considered lenticular like the dotted one here. So, that the corresponding load, the load falls considered close to the you can say that r axis, because the power factor is pretty large in general. So, if the corresponding load you can say that patterns happens to be there here in this area. So, instead of the circular, if you make the corresponding lenticular characteristics for that relay characteristics, where we expect the load encroachment problem, then we say that we have gain on this situation. So, what you see that if this is the load line perspective and below this you can say that is the expected load. So, what we see can say that we see here that this line segment, this portion from this lenticular this point to this circular point here on this load line with an angle of 30 degree, this is the gain or improvement on loadability improvement by considering lenticular characteristics leaving circular characteristics with mho. So, that what you see that for issues where we will expect such issues, a transmission system for the relay characteristics, then you can switch over the corresponding from you can say that the circular characteristics to the lenticular characteristic to exploit this advantage on more loadability. It means that even the corresponding load enters into this portion also, the relay will not operate, because it is having now lenticular characteristics, not with mho characteristics. Another option, add blinders to the characteristics to limit reach along the real axis. So, as I said, this is the portion for the load. So, what you do that, suppose this is a mho relay characteristic or so, you put two blinders, the dotted line blinders. These are parallel lines with the load line, the transmission line impedance line impedance line, this is impedance line and it parallel with that. So, what you do that, even the load comes this portion, the relay will not trip, because it is beyond the blinder, it is beyond the blinder, even though it is inside the mho characteristic. So, the relay will trip when it is inside the characteristics, and also for this you can say that right hand blinder it is left of that, then only you can say that it will be. So, if the corresponding point falls within the blinder and also in the characteristics, then only you can say that the relay will trip, that will ensure that this is a fault. So, therefore, in this case, because the relay will not trip in this portion also. So, we will have a, because this is the area of you can say that the load. So, we have a gain of you can say that this portion, and that is what the loadability improvement by using the blinder concept. The third one we will see that for remote zone 3 protection, this is about the zone 3 protection, use an impedance relay offset into the first quadrant. So, what you do that, the problem you can say that we see that the load encroachment issue, if you see that you can say that the load you can say that may come inside this one. So, instead of that, to have this you can say that the corresponding line backup protection for this line zone 3 will be available here. This zone 3 will you can say make an offset one and like this, not like this one. So, therefore, the relay you can say that here see for any fault in NP which should be taken care by this relay. So, that characteristic becomes this, the offset one, not this one. So, thereby what you say that the corresponding relay you can say that the loadability improvement will be this portion in this case. So, that is about the backup protection from relay RM for the NM question. So, the disadvantage of this is a fully offset mode relay will only cover a small portion of the protected line depending upon the offset. Of course, the purpose is for the backup. The other one is a quadrilateral characteristic resetting. So, what we see here that in this kind of situations, if we expect to the cover the RF for you can say that let us say zone 3 relay having this, but if the corresponding relay characteristic is expected to having load encroachment issue, so we reduce the coverage. You reduce the coverage and thereby you can say that we can exploit the advantage of this portion as the improvement portion. So, even you can say that a load you can say that falls in this area also, it will not go for a trip decision. So, this we do not require everywhere, we require when there is load encroachment issue. The other one option is that the enabling the load encroachment function. So, we have a special characteristic for this load perspective. So, typically we can set these two lines 30 degree, but and then you can say that in both the sides forward region and the reverse region, this we consider the load. So, therefore, you can say that in the mode characteristic also this portion you can say that will be not allowed to consider trip. So, therefore, we have an advantage or gain in the improvement on the loadability perspective. So, any point you consider inside this portion is a considered as a load and the relay will not trip. Relay will trip when they consider it is beyond this and inside the characteristics. However, the 30 degree is not you can say that fixed option, depending upon you can say that it is being observed that different emergency situation this corresponding this line setting 30 degree may not be proper. So, in that kind of situation and all these things this should be a different angle perspective. Now, we see there are different options for mitigating the maloperation issue associated with load encroachment. We can have a better option also by combining 2-3 you can say that such options for better performing in this regard to have a better accuracy. So, what we see you can say that is that load encroachment creates problem and it needs mitigation strategy and there are different options available. Now, there is another issue. If a fault happens to be there during a load encroachment period, try to understand the apparent impedance seen by the relay is in the load encroachment area and at that time the relay is blocked because it should not trip and a fault happens to be there in that zone. Because this is a fault, so the relay must trip, the relay has to take care. So, therefore, the corresponding blocking phenomena because of the load encroachment issue prior to the fault must be withdrawn. Then how to have this in the relay characteristics? The load encroachment and blocking element is to be bypassed. One option, easy option, most of the faults are unbalanced. So, what do that we there will be lot of negative sequence current. So, negative sequence current upon positive sequence current greater than the threshold small value let us say 10% or so. If this sequence current becomes significant as to this threshold, then we ensure that there is a fault in the system. So, we can bypass the load encroachment function. There are other options also. Negative sequence overcurrent element can be used to bypass the load encroachment also, simply from the negative sequence overcurrent also we can do. Third option, during a fault the relay voltage will go down, will be low, there will be voltage sag issue, voltage dip issue. So, if the low voltage say less than 0.7 pure is observed in the any of the phases, then it is considered that this is a fault and the load encroachment function can be bypassed at that time. So, thereby this approach, this allows the distance, you can say that, relays zones to trip and using the full zone area associated with that zone. So, what we see from all this, that load encroachment is a problem for heavily loaded line or long line, and also associated, you can say that, at the zone 3 of the relay. To overcome that, there are different options available, including the load encroachment function. However, fault may occur during the load encroachment one. To bypass the load encroachment function or so, we require special other principles features, and that will lead to the corresponding solution for that perspective. Thank you.